Greetings everyone. In this video I am going to demonstrate serial UART communication between two ATmega8s. Here the circuit for the project is shown. Both the transmitter and receiver is using 8 MHz clock speed. The circuit is pretty simple. In the transmitter end, a button is connected and it's pulled up internally with software. At the receiver end, in port C, a 7-segment LED display is connected. The display that I'm using is a common anode type. That means the common for the LED display is connected with VCC, and the segment which I want to light up is fed with a low voltage. The TX of the transmitter is connected with the RX of the receiver. An important thing here to notice is the ground for both receiver and transmitter needs to be common. Baud rate for the serial communication is the speed of the data transmission. I'm using 9600 as the baud rate. Let's discuss about the registers that I'm using here. UBRR register is used to determine the baud rate. We can use 10 bits to define it. What should be the value of UBRR can be calculated with the equation. Here FOSC is the clock frequency of the microcontroller, and if we put our desired baud rate, that is 9600, we will get a value of 33 hex, and that I have put in the UBRR register. The next one is USART data register. With UDR we can indicate both TXB and RXB registers. While transmitting data, TXB register will be populated, and while reading from the UART, RXB register will be pointed at UDR. In the UCSRB register, TXEN and RXEN pins are enabled. In the UCSRB register, TXEN and RXEN pins are used to enable the transmitter and receiver respectively. The RXCIE bit is used to enable the receive interrupt. In the UCSRC register, UC pole indicates the clock polarity. We have kept it 0. That means the data will be read on a falling edge of the clock. UCSZ0 and UCSZ1 indicates the size of the data that is transmitted and received in USART. We are using 8 bits data communication, so we have kept these 2 bits 1. USBS bit indicates the number of stop bits. We are using 1 stop bit. UPM0 and UPM1 determines the parity. We are not using a parity. The UMSEL bit determines synchronous or asynchronous operations. As we are using USART in asynchronous mode, we have kept 0 in this bit. UCSRC register and UBRR high register is shared in the same location. URSEL bit, that is USART register select bit, determines which register is being used. So if it is 1, UCSRC register is being read and written. If it is 0, then we are communicating with the UBRRH register. Next, let's look at the transmit code. We are primarily using 2 functions here. First one is to initialize the transmission, and second one is to send a byte from the transmitter end. A count variable is used to track the number of times the button is being pressed, and I have called the transmit init function. Then in the while loop, 0th pin in port B is being tracked. So if the button is pressed, we are waiting for the UDR register to be emptied. That means we are waiting for the previous data to be transmitted. If the data is not fully transmitted and we are writing to UDR register, the data will be overwritten. After waiting for it, we are sending a byte to the receiver, and the delay is used for button debouncing. Let's look at the transmit init function. First, we are enabling the transmission in UCSRB register. Then in the 31st number line, we are defining the data transmission size to be 8 bits. Next, UBRRL register is being loaded with 33 hex value. Then with SEI function, we are enabling the global interrupt. Then pin 0 of port B is being declared as an input pin, and then this pin is being pulled up. That is, it will be normally high if the button is not pressed. The next one is send byte function. the data of the counter variable is being written in UDR register, and the character version of 0 is being added to show the value in a character mode. Next, let's look at the receiver end. First, a constant array is declared for all the 10 characters in 7-segment display. In the main function, receive init function is called. In the receive init function, we are enabling the RX pin and also the receive interrupt. Then we are declaring the data transmission as 8 bits. Then UBRR register is written 33 hex to indicate the baud rate as 9600. Then global interrupt is being enabled. Next, to show the output, port C is being declared as output port. Also, I am using DDR-D pin 6 as pin 6 of ATmega8 is occupied with some other functionalities. Next, the interrupt service routine is written. First, we are declaring a variable temp and it contains UDR mod 10. That means we are storing the last digit of UDR. Then in port C, the specific value for the digit is outputted. Also, I am outputting the 6th bit in port D pin 6. This is it for the receiver's code. Let's program the two chips and see the output. Thanks for watching, everyone. If you like this video and want to see similar contents in the future, please leave a thumbs up. Thank you.